Okay, let's talk about functions. Functions allow us to compartmentalize code and to conceptually isolate our tasks. And when you create a function, you have to follow a format similar to this, where you create the return type, the function name, and a list of parameters to declare the function. And then within the body of the curly braces is all of the code that your function is going to execute. And then your function ends with a return statement where it returns a value of the type that you are expecting. And so we'll go into details on how that gets formatted. So when we think about using functions to compartmentalize code, if you have the same types of code being run in multiple places in your application, you might run or create code in a way similar to this, where you have a top-down view of your code, and you may have some code, let's call it find max, where it's going to find the maximum of say a series of integers. And you may need to do that multiple places in your code. Well, you could certainly do copy and paste that code into 3 different places in your application. And as your application executes, it's going to execute from a top down. So each line of code will follow the previous line of code in a top-down way, and we'll get to the end and we will have executed our logic of our program and been completely successful without any functions. So why do we then create functions in the first place? Well, what we would do here is we would take and realize that the find max code is being used multiple times. So what we could do is we can pull that find max code out into its own little compartment, its own little section called the function find max. It's the exact same code that we had running before, except we're going to pass information to it and from it in our code. And so our main code would now look like this. Everywhere that we were originally having the entire structure of the find max code, we would now have a reference, a function call to the find max code. So in execution, we would start at the top of our program. We'd execute down until we hit this first function call. And then the function call would transfer control to our find max function, passing in any parameters as information into the function, and returning back any answer back from the function. We'd be back in our main code again, exactly as if we had executed this function in line. We would execute down to the next function call. Again, it would transfer up to our function. Our answer would transfer back. We'd execute again, same round trip. So the same piece of code gets run multiple times by referencing it with a function call. And that means that changes to the code are easy to make. If I found out later that I wanted to implement a new algorithm to find the max, maybe I discovered one that was faster. In the old scheme, I would have to change it here, and here, and here. If it was some code that was used 50 times in your application, you'd have to go and find every single instance of that code in order to make the replacement. With a function call, I change it one time, and every single time it's called, it has the new code implemented. So here's a definition of a function in C#. It's going to include a return type, and here you see that the return type of this function is int, and it could be void. Void is a valid return type for a function, meaning that you're not going to return anything. So any types of things we can use to declare variables, we can use to declare return types from functions. Everything function is going to have a name, so find max is the name of this function, and it accepts parameters. Parameters are a list of variables that appear inside the parentheses, comma separated, and here we have an integer array that is going to be called numbers. Numbers then appears, because it's declared as a parameter, numbers is now available as a variable local to the inside of my function. Functions also return a value upon completion, and the return type has to be the same as the return type declared in the function definition. So it was originally an int, so here we can return max, and since max is an integer, it's acceptable. So the value of find max will now take on the value of max that was calculated inside of it. So how do we use these things? After we've defined them, we have to call them. So here's an example of using the find max function that we just declared as the right-hand side of an assignment statement. Since the functions return values, they can appear anywhere that a variable or some other thing that has a value can be used. Here, it can appear on the right-hand side of an assignment statement. So find max of some integers will pass the copy of some integers into the function and return back a value for the biggest. If we were to execute this, we would end up with the sum integers variable being passed in to the function. The function would return back the largest of those answers as the variable the biggest, and so we would see on the screen the max is 22. So when we pass parameters, we pass them by value in most cases. This means that a copy of our variables, a copy of our parameters, is created for the function to operate on. So here, if we had this external array called sum integers, as soon as we make the function call, as soon as we make the definition here, sum integers would take on those values. When we make this function call with this parameter, the copy of sum integers is passed over into numbers. So numbers now stores a copy of that same data. This is not a direct access into the original variable sum integers. It's simply a copy of the function sum integers. So if you make modifications to the numbers array inside of the function, it does not modify the functions or the variables in the external array. If for some reason you need to modify the original copy of the parameter, you can pass it by reference. Generally, this is used much less frequently than creating a function that returns the answer as a return value. So you can do it by putting the word ref in front of the variables. So that's the basic definitions of functions. Use them to replace repetitive code and to compartmentalize your concepts. So for example, if you're creating code to do square root, you create it as a square root function. Then whenever you're in line with your code, you just say the square root of x, and it's conceptually very easy to understand code that way, because you can name your functions in a way that give semantic meaning to your use. Okay, let's build a function, and then we can talk about the topic of variable scope. And so here's my main function. This is always the starting place of any console application. So in a way, we've been using functions all along. All the code we've been writing in our console examples have been inside of this main function. This is the function that receives the initial entry point for your application. And so we can put code in here. And so I think what I'm going to do is I'll do a little demonstration of let's build a function. We're going to find the area of some rectangles. And of course we know that the area of a rectangle is equal to its length times its width. So I could, for example, declare a couple of integers. We'll say the length is equal to 10 and the width is equal to 8. And of course I could declare the area variable, and this would equal length times width. So console.writeLine. So obviously no function involved here. If we run that, we should get the area of a 10 by 8 rectangle is 80. So seems to be working fine. Now if I was going to convert this into a function, I am going to go somewhere else outside of my main. So I'm going to declare this function outside of this particular definition. So I can do it below here, and I would do static, and what kind of number is the area going to return? Well, if we're only passing integer values, this is going to return an integer. So we'll make a version that is the integer function. So I'm going to call this rect area for the area of a rectangle. And I'm going to pass in two parameters. I need to pass in the length and the width. Both of these are going to be integers. So I will call this capital L and int capital W. And we'll talk about variable scope here in a second. And it's currently underlined because it's expecting me to return a value. So I can declare a variable inside here, A, and it's going to equal L times W, and I'm going to return A. Now, I could have just returned the actual value L times W. That would have worked too. Trying to put a little bit of code in my function so we can see how it works here. Okay, so back here in my main program then, instead of this line of code, which is calling my length times my width, I could instead say that the integer area is equal to, and now I'm going to call my function rect area of L and W. So if my length is 10 and my width is 10, then these will pass in as parameters. So what I'm going to do is I'm going to throw a stop in here, and we're going to watch this function proceed. So I can now proceed one step at a time, and you'll notice that I have these locals window down here, and you'll see that length is both 0, width is 0, and area is 0 at the moment. So I'm going to step through here one line at a time. So I will step into. So you can see that down here at the bottom in my locals window that L has taken on the value of 10 after executing that step. W is now 8. So the area now, where does the area get calculated? Well, as soon as I call the step into, you'll notice that program control has transferred into this particular area. And you'll notice down here in the locals window, which is showing what are known as local variables, or variables that are in my local scope, that the little l, the little w, and the capital area are gone. They no longer exist. They are only defined locally to this static void main function. And so once I'm in this static rect area function, the only variables that are here are the variables that are declared as parameters and any variables I declare inside of here. So if I step into, I get to my first line, the area A is now equal to 80. I'm going to return A, which means that this function will take on the value of 80. So if I step, when I come back here, you'll notice that when I complete this statement, area is now taking on the value A. So area gets the value of that function. And then if I just go ahead and run it out the rest of the way, I get the area of a 10 by 8 rectangle is 80. That shows you an example of how we can build a function, and it also shows how we can transfer the program process, where it's executing the next statement gets transferred in here, and it also demonstrates the difference between variable scope. Here, L and W small case are in scope, and here they are not. So if I tried to use them inside here, like if I tried to say little l is equal to, you'll notice that the editor is already trying to do IntelliSense on me, and is trying to tell me there is no little l. Or if I tried to use area is equal to, you'll notice it doesn't exist. And so they go out of scope when you leave the function. They come into scope when you enter the function.